Welcome to Archiversity online courses. In my previous lecture, I've shown you how to frame a hypothesis and test a hypothesis using a chi-square test on a categorical data. In this lecture, I'll extend the same, that is conducting a chi-square test of independence with a different data set. That is, in this video, we'll measure the association between experience of employees and their opinion on suitability of the training. Whether employees with a different experience levels have the same opinion on the suitability of the program or not. Because those people who have a high experience may consider that the training program is not suitable for them, and the people who are with less experience may consider that this training program is very much suitable for them. So to know whether this training program is suitable for all set of participants or not, we use chi-square test of independence to test the hypothesis. So here is a questionnaire. The experience of employees are measured on three labels. One is 1 to 5 years, then second is 5 to 10 years, and third is 10 to 15 years. Then the suitability, that is employees' opinion on suitability of the training for them, is measured on a Dictomus scale. That is 1 is yes and 2 is a no. So as both are categorical variables, and one is a Dictomus and second one is a demographic one, to test the hypothesis we need to run a test of independence, that is a chi-square test. So here the equation that we use to calculate the chi-square test is observed frequency minus expected frequency raised to the power of 2 upon expected frequency. And observed frequency we can calculate with the help of a pivot table, and expected frequency we need to write a small formula in Excel. Then to get the chi-square value, we need a degrees of freedom. Our degrees of freedom is number of rows minus 1 times number of columns minus 1. So first we calculate the observed frequency. For that we need a pivot table. So click on your database, any one cell of your database, then click insert, then click a pivot table and select a new worksheet, click OK. So pivot table is ready and pivot table fields. What is that we are saying is experience and suitability. So experience bring to the rows, then suitability bring it into the columns box, then once again bring suitability to values. If you observe here, 1 should be the yes and 2 should be no, but here it is no came first and yes second column. So you can simply move this one. So select the no and hold this box and pull it onto the right side, that is next to the S. Now you can see S comes first, then no. So your observed frequencies are ready. Now copy these observed frequencies along with the grand totals. Copy here and we'll paste here. Name this as observed. Next what we need is we need to calculate the expected. So our expected frequencies, the formula that we use is, to get the expected frequencies we need to use this equation, that is expected frequency equals to row total times column total upon grand total. So we copy these values here and paste it here. Remove the values because we need to calculate the expected frequency. So our expected frequency of S, this equals to row total, here is a row total, select this one, times column total, select this one, upon grand total, select the grand total. Now as we want a column J to constant, so here we'll place or insert dollar symbol in front of a column J. Then we want to make the row 7 as a constant, so here we insert a dollar symbol in front of a row number. Then we want to make this cell, that is a grand total, constant. So to make this cell constant, we place a dollar symbol in front of a column name as well as dollar symbol in front of a row number. Then click enter. Now drag this down and onto the right. So your observed frequencies are calculated. So just to cross check, we'll calculate the grand total by using Excel function sum equal to sum, then select all the 4 values here, close the bracket, press enter. Now 150 observations. You have 150 observations in observed as well as in expected. That means your calculated expected frequencies are correct. Then to get your chi-square test, so your chi-square test, there is a power value, chi-square p-value. For this we use Excel built-in function chi-test is equals to chi-test. If you are using a latest versions of Microsoft Excel, then you can use chi-square distribution RT, that is a right tail, but I am using a chi-square test. Double click on this, then actual range. So here is the actual range, comma, and expected range. Close the bracket, enter key. So your chi-square value is, that is the power value is 0.44. We compare this with our significance level of 0.05. That is, we are testing it at a 5% significance level. If calculated power value is greater than 0.05, we accept a null hypothesis. Accepting null hypothesis indicate that the opinions expressed by individuals with 1 to 5 years of experience and individuals with the 5 to 10 years of experience are different. That is, their opinions are independent. In other words, we can say that there is no association between the suitability of a training program on employees with 1 to 5 years and 5 to 10 years. Maybe some of the employees may consider this as very suitable, some may not consider it as a suitable. So there is no association of the opinions expressed here. Now to get a chi-square distribution value or chi-square value, we use Excel built-in function, that is chi-inverse. So equal to chi-inverse, double click on this, then the probability, already we calculated a probability value here, select this one, place comma, then degrees of freedom. So our degrees of freedom is number of rows minus 1 times number of columns minus 1. So here we have a 2 rows and 2 columns. It is 2 minus 1 is 1 and 2 minus 1 is 1. So 1 into 1, 1. So 1 is the degrees of freedom. Then close the bracket, press enter key. So the chi-square value is 0.59. This is a very low value. That's the reason why we are accepting a null hypothesis, that is the opinions expressed by two sets of experienced employees are independent. There is no association between the opinion expressed by two different groups of employees. Thank you. Thank you for watching the lecture. In my next lecture, I am going to explain you how to calculate a rank correlation on a continuous data